In this video, we'll analyze the retrofit of a pumping system with a variable speed drive. I'll move to the energy page. From the energy end use dropdown, I'm going to select pumps. We have two choices here, closed loop pumping called pumps or water pumping, an open loop system. I'm going to choose the first method, closed loop pumping system, which would apply to say a chilled water circulator. In my base case, I have a standard efficiency motor driving my pump. The motor size is 20 horsepower. RatScreen from its database pulls the efficiency, and I have to enter the loading or the load factor for that motor, how heavy loaded it is. I determine that it's 75% loaded, and now RatScreen requires me to specify the efficiency of the pump in the base case situation. This is going to come from shop drawings or maybe manufacturer specs. In this case, I'm going to use an efficiency of 60%, which is appropriate. Again, if you're stuck in any of these situations, you can simply click on the help and you'll get an idea of what a typical range might be in this situation. Next, I have to specify what type of flow I have here. Do I have variable or fixed flow? In this situation, I have a variable flow situation, but I'm achieving the flow by not variable speed, which is the better way to do it, by throttling, which is not so good. Now, RatScreen asked me for a flow range. The flow range low means that I'm heavily throttling this pump. A flow range of high, which is the other choice, would be lightly throttling. In this case, I'm heavily throttling the pump, so I choose low. Operating hours for this pump are specified as 16 hours a day, and now I've completely specified my base case. I'll copy base to propose to generate my proposed case identically, and I'll work through specifying the proposed situation. If I'm going to choose a variable speed drive in the proposed case, more than likely the motor that comes with that will be in fact a premium efficiency motor, likely a inverter duty rated motor. That's a more efficient motor. We'll specify that here. If I'm unsure of what the proposed case efficiency of the pump is, may not have a lot of detail, I'm going to simply use the number I use in the base case of 60%. That's probably a reasonable starting point, but it would be something that would be worth researching to enhance your calculation here. Now, we are in a variable flow situation. We are heavily throttling, which is low flow range, but we are now going to achieve the lower flow through variable speed, which is a more efficient way to do it. At this point, I simply have to enter the cost of this installation, the drive and wiring and so on, $5,000. And with the 64% savings, I go to my include measure and I see I've got a 1.3 year simple payback. This is a good project.